this section, we are going to look at real numbers and properties with real numbers. The first thing that I would like to highlight is the set of real numbers. So this gray box is the set of real numbers, and then we have the breakdown of different types of numbers. This is a Venn diagram. It just looks a little bit different because all of the sets are building on one another. So I'm going to start in the middle with the natural numbers. And now the natural numbers are the numbers that you normally learn when you're little. So you start, they occur naturally. So we have like 1, 2, 3, 4, etc. Sometimes they're also called the counting numbers. As we move out, we have our next group, which is the whole numbers. Now, you might think logically, well, what did I learn next when I was little? And that was the value of 0. So whole numbers are the numbers 0, 1, 2, 3, etc. So the number 3, for instance, is a natural number and it is a whole number, whereas 0 is only a whole number at this time. Then we started learning about, well, what if we take away more than what we started with and we ended up with negative numbers? So that is what we call integers. So we still have all the natural numbers and the whole numbers. Now we add on negative numbers. Moving out, after you learned about negative numbers, or sometimes we learn about fractions before that, we have rational numbers, and that includes the terminating or repeating decimal. So 1/2 is a terminating decimal because it's 0.5. A repeating decimal would be like 0.33333, which is the 1/3. So if we take a look at just these set of rational numbers, so if we look at, well, we'll go back to the number 3. Number 3 is a natural number, it's a whole number, it is an integer, and it is also a rational number and a real number. So 3 fits in all of those sets. Let's take a look, maybe -4. It is not natural, it's not whole, it is an integer, it is a rational number, and it's a real number. So -4 is an integer, rational, and real. A number like 3/2 would be just a rational number and a real number. Then we also have some numbers, well, what if they don't fit in that set at all? Like pi, for instance. Those are called irrational numbers. So pi is an irrational number and it's also a real number. So you're looking at fractions that become decimals that don't terminate and don't repeat. Those are all irrational. Interval notation might be new to you, but inequality should look familiar. So we'll recall for a minute that this symbol here is standing for less than or equal to. And this one here is greater than or equal to. Make this symbol here is just greater than. And this symbol here, down here, is just less than. We note the or equal to part with a square bracket. So it becomes square, like here. The not including are open. Now if we go to our inequality, our first inequality here, a is less than or equal to x is less than or equal to b. A and b are placeholders for numbers. So we could have like 2 is less than or equal to x is less than or equal to 3. The or equal to, if you remember from algebra, we fill those in with solid or closed circles. Sometimes we'll refer to them. and we'll use the closed brackets. The a is less than x is less than b, we use an open circle. So we use the parenthesis or the open notation when we encounter those. So a is less than or equal to x is less than or equal to b. We have close for the or equal to, open for the just less than, and we can symbolize it symbolically with our number line. So take a look at all of those. Then we get to the ones that continue on forever. So x is greater than or equal to a. So like x is greater than or equal to 2. The value x can be any number that's greater than or equal to the a. So or equal to, we fill it in, and then we use an arrow to indicate that it goes on forever in that direction. Infinity is the direction that it's heading. It's our destination. Infinity is the largest number. So we can start at A and go to infinity. Whenever you're writing these in interval notation, you should always do the smaller number on the left and the larger number on the right. So if we do our next one, x is greater than a, it's just an open interval. So we'll indicate it. Now infinity is technically not a number, okay? Infinity is more like a destination. Infinity is always an open circle, okay? It's always an open interval. So now when we go less than, so our arrows are going on forever to the left, our smallest number that we'd go to is negative infinity, because as the numbers get smaller, they're getting smaller negative numbers. So we have negative infinity to b, closed if it's or equal to, open if it's not. And then all real numbers we can indicate as negative infinity to infinity. So now we're going to do an example, and it will be starting out a review problem. So you've done these before. I just want to scroll this a little bit down. So we're going to graph -3 is less than or equal to x and is less than 7. Now you can, if you want to, create a whole number line, but I would suggest just do -3 and do 7. Now we have -3 is less than or equal to x, so that should be a filled in circle at -3. My calculator, or my computer's a little off, so we'll fix that for the future. X is less than 7, so that should be an open circle. So the open circle means that that value is not included in this set. So it can't be exactly 7, but it could be 6.999999, etc. You get the idea. So it can be infinitely close. And then indicate that it's all the numbers in between. Now, when you're doing this on assignments, it is difficult to get the coloring. So if you want, you could use a different color or just do it a little bit thicker like I did. Some people do like a little squiggly. Just make it clear which value you are or where you're shading it. So that's should be a review problem. Now we're going to also write it as interval notation. So -3 is my smaller number. 7 is my larger number. It is -3 is less than or equal to x, so I use my square bracket for or equal to, and it's less than 7, so I'll use the open. Let's go on. We're going to graph x is less than -5 on a number line. So we have our number line, or sorry, it's less than 5. I might have said -5. So we have 5. It's less than, so we're going to use an open circle. And all the values less than 5 are to the left. If you want to, you can draw in more numbers if you need to for your number line. So if you want to, you could have 4, 3, 2, etc. 6, 7, 8. So if you want to, you can do that. Now use interval notation. So my smaller number, I'm going to come back to. My larger number, in this case, is 5, and it's open interval. So now all my values are going far to the left, so the smallest value is going to be negative infinity, and that one is always open. Absolute value is the distance a number is from 0. So if we're looking at absolute value of -4, we can look at a number line. So we're looking at -4 back here. So we can count 1, 2, 3, 4. So that is 4 spaces from 0. So 10, I can do the same idea, but I think we can figure out, well, 10 would be 10 spaces from 0. So the idea behind absolute value isn't that, oh, it's a positive number. Absolute value represents the distance a number is from 0. So if we're looking for the distance between A, which is 140, and B, which is 30, I can set this up. Well, what's the distance between the two? I can do absolute value, subtracting the two. In either way, it doesn't matter. So we can represent distance with the absolute value. Either way, both of those are 110 spaces away. A lot of times we don't take the time to think all that out. We just say, well, 140 to 30, I would go 110. But that is a way that we can do it. Now, let's talk about some algebraic expressions. So algebraic expression is a collection of letters, which we call variables, and real numbers, which are constants. So those are the numbers in front of the variables in the numbers themselves, combined with the operations of addition, subtraction, multiplication, division, and exponentation. That means you're making it an exponent. And the terms are the parts that are separated by the addition or subtraction. The numerical factor of a term is the coefficient. Those are the numbers in front of the variables. The constant is just a number. And to evaluate it, you would substitute a number in. So if we're looking at x squared minus 5x plus 1, we're looking for addition and subtraction. So the terms, we have x squared. We have a negative 5x and a 1. Those are our three terms. Our coefficients are the numbers in front of the variable. So our terms with variables are x squared term. The coefficient is 1. There would be a 1 in front of the x squared. And there's a negative 5 with the x. So our coefficients are 1 and negative 5. Our 1, the number 1 here at the end, is a constant. So this one is a constant. Now we need to evaluate the expression for negative 1. So I'd substitute the value in. So negative 1 x squared minus 5 times negative 1 plus 1. So we're substituting in the 1 or negative 1 for the x. Make sure that you actually do the squaring. This is where your calculator will start to give you wrong answers because it will do only what you tell it to do. So if you type in negative 1 squared, it will square the 1 and then make it negative. You should be putting parentheses around it. So negative 1 squared is negative 1 times negative 1, which is positive 1. Our order of operations, say we do the exponent first, then we do multiplication. So we have negative 5 times negative 1, which becomes a positive 5. And then our last order of operation, we do addition, subtraction, left to right. So we have 1 plus 5 plus 1, which is 7. So whenever you're doing those, you should substitute in the value.